In the previous video, we had studied about loss due to elasticity of the concrete. In this video, let us know about loss due to shrinkage of concrete. So for this, you need to refer IS 1343, page number 25. So what is this shrinkage? Shrinkage means this is a contraction of concrete due to a chemical changes. This depends upon interval of time and moisture condition. So loss of stress due to shrinkage of concrete, the formula is epsilon Cs into Es. So what is this epsilon Cs? Epsilon Cs, it is nothing but total residual shrinkage strain, and Es, it is already known, that is Young's modulus of steel. Again, this total residual shrinkage strain, that is epsilon Cs, again its changes depends on the member, type of member. So whether it is in a pre-tension and post-tension, we need to analyze whether we are doing a design for the pre-tension or post-tension. In case we are doing a design for the pre-tension member, your epsilon Cs value will be 0.0003, and whereas for the post-tensioning member, your epsilon Cs value will be 0.0002 divided by log 10 of T plus 2. So what is this T? T is nothing but age of concrete at transparent days. Okay. And suppose is it a 7 days, 21 days, or 1 year, or 8 days? In the in the question, if they have mentioned that number of days, they will be mentioning it. So in case for the post tensioning member, in case if you are dealing with a post tension member, they will given a number of days also. So that number of days is T. So first we'll solve a first problem, that is the first problem is a concrete beam is pre-stressed by a cable carrying a pre-stressing force of 300 kilonewton. The cross-section area of the wire in the cable is 300 mm square. Calculate the percentage loss of stress in cable due to shrinkage of concrete for pre-tension and post-tension of beam. ES, that is nothing but your Young's modulus of steel, is 210 kilonewton per mm square, and age of concrete at transfer is 8 days. That is nothing but your T. Okay. First, write down all the given data. What are the given data has been given over here? So they have given a pre-stressing force. So that is nothing but your P. P is 300 kilonewton. So and the cross section area of the wire of the cable is, that is nothing but area of steel, that is 300 mm square, and they have given a Young's modulus of steel, and they have asked you, and they have given a T also, and they have asked you to calculate the percentage of loss for pre-tension also, and as well as for the post-tension member also. So what is this percentage of loss? Same as your shrinkage velocity of the concrete, what you have done, no? The percentage of loss equals loss of stress divided by initial stress. Initial stress, it is nothing but P by A. P is also known and A value is also known. So P is how much? 300, and A is how much? 300 mm square. Okay. So the A is 3000 mm square. Okay. Mm square. So P by A is known, that is 1000. Newton per mm square. So next it is P by A is known. So next you need to calculate your loss of stress. Loss of stress is epsilon Cs into Es. Epsilon Cs for pre-tension member, the value is 0.003, and your Young's modulus of steel is 210. When you substitute both the values and calculate it, you will get it as 0.063 kilonewton per mm square. So both the values, that is your losses of stress and as well as your initial stress, when you calculate that, so you will get your percentage of loss as 6.3%. And now so for pre-tension member it is done, and you need to deal with post-tension member. So entire thing is same as like pre-tension member. The only major difference is epsilon Cs value. So as it is in a post-tension member, your epsilon Cs, the formula will be changes. So that is 0.02 divided by log 10 of T plus 2. So here your T value is also known, that is 8. Okay. So when you substitute entire value, epsilon, calculate your epsilon Cs, then again you substitute to a loss of stress formula, that is epsilon Cs into Es. Epsilon Cs is 2 into 10 to the power of minus 4 into Es is 210. So you will get to your value as 0.042 kilonewton per mm square. So calculate your percentage of loss. Percentage of loss equals loss of stress divided by initial stress. So loss of stress will be 0.042 into 10 to the power of 3 divided by 1200. So you'll get it as 4.2%. So now let us concentrate on loss due to creep of concrete. Actually the very first loss was elasticity of concrete and the second loss was shrinkage of concrete. So shrinkage of concrete, that is also a time dependent losses, whereas the creep of concrete, that one also a time dependent losses. For this you need to refer page number 20 of your code book, the clause 19.5.2.1. So coming to this creep of concrete, what is this creep? Creep of concrete means the deformation of concrete which depends upon the interval of time, okay, setting time, to which the member is loaded. The sustainable pre-stress in the concrete of pre-stress member results in creep of concrete, which effectively reduces the stress in high tension steel. The loss of stress in the steel due to creep of concrete can be estimated in two methods. Okay, one is ultimate creep strain method and the second one is creep coefficient method. So let us know what is this ultimate, what is the difference between this ultimate creep strain method and creep coefficient method. So whereas ultimate creep strain method, the loss formula will be epsilon cc, that is nothing but ultimate creep strain, into Fc, that is nothing but stress in concrete at the level of steel, and Es, it is nothing but Young's modulus of steel. Whereas creep coefficient method, the loss equals phi into Fc into alpha E. Phi is again, it's in a creep coefficient, and Fc, it is again stress in concrete at the level of steel, and whereas alpha E, it is in a modular ratio. Modular ratio, it is nothing but the ratio of elasticity of the modulus of elasticity of the steel to modulus of elasticity of concrete. So let us know what is this phi. Phi value, again the creep coefficient equals creep strain divided by elastic strain. Okay, so Fc is stress in concrete at the level of steel and alpha E, same modular ratio. So in this creep coefficient, how do you get your values? It depends on the age of loading. So for 7 days your creep coefficient will be 2.2, and for 28 days creep coefficient will be 1.6, and for 1 year creep coefficient will be 1.1. In case in the question if they have mentioned the age of loading, you need to take a creep coefficient according to as per the loading conditions. In case if the question directly, if they have mentioned the phi value, and that is nothing but your creep coefficient value, so take that value only. Okay, so let us deal with problems. The first problem of your creep coefficient is a pre-stressed concrete beam of rectangular section 120 mm wide and 300 mm deep is pre-stressed by 6 wires of 6 mm dia provided at an eccentricity of 55 mm. Full stop. The initial stress in the wires is 1150 Newton per mm square. Find the loss of stress in steel due to creep of concrete. So they have given Young's modulus of steel is 2 into 10 to the power of 5 Newton per mm square, and also they have given Young's modulus of concrete, that is 3 into 10 to the power of 4 Newton per mm square, and they have given a phi value, that is 1.5. In this question, they have not mentioned the type of method in which you need to calculate the losses, whether it is in a ultimate strain method or a creep coefficient method. But you can definitely make out that they have given a phi value. It means that is in a creep coefficient. So in case if you need to calculate your what ultimate strain method means, what you need to do in the ultimate strain method, you need to have an epsilon cc, that is an ultimate creep strain. Okay, in this they have not given a in the problem they have not given a ultimate creep strain value, only they have given a phi value. Phi value, it is nothing but creep strain. Okay, that is second method. So you need to use your second method, you need to calculate by it second method. Okay, first write down all the given data. Breadth has been given 120 mm and depth has been given 300 mm, and eccentric distance also has been given, that is 55 mm. Young's modulus of the steel is 2 into 10 to the power of 5, and Young's modulus of the concrete is 3 into 10 to the power of 4, and the phi value, that is creep strain value, also given, creep coefficient value also given, that is 1.5. So write down all the rectangular sections. So make out all the write down all the dimension with the dimension. Rectangular section has been written. So next, calculate your, first you calculate stress value. So that is first calculate your stress. Stress is P by A. P by A, so they have given a stressor. Initial stress has been given, that is 1150 kilonewton. Initial stress also given 1150, and P is unknown factor, whereas A it is given in it. I mean they have given in the question that is pre-stressed by 6 wires of 6 mm dia. It means pi by 4 into d square into number of bars. So you will get your P value. Okay, and the loss of creep strain, how do you calculate your creep strain, the loss in the creep coefficient concrete? So loss equals phi into fc into alpha e. Phi it is known value, fc you have a formula P by A plus PE by Z, and alpha e it is in a ratio between ratio of your elasticity of steel, modulus of elasticity of the steel to modulus of elasticity of concrete, that is ES by EC. So first calculate. So what is your FC? FC is nothing but P by A plus PE by Z. So first you need to calculate your P by A. P by A. So P is 195.02 into 10 to the power of 3, and A is area of your rectangular dimension, rectangular section. That is 120 by 300. So next, what you need to calculate? PE by Z. P is known, that is 195.02, and E is also known, that is what is your E value? E is 4.55, that is eccentric distance has been given, no? So that value, and Z you need to calculate your Z value. Z is BD, as it is in a rectangular section, your sectional modulus will be BD cube by 12 divided by Y. Y it is nothing but your eccentric. Actually in the previous video I mentioned that for in a loss problem your Y will be E. Okay, so B is 120, D is 300 divided by 12, and Y is E, that is 55. Substitute all the values, you will get your Z value. So and now you know your P by A value also and P by Z value also known. Substitute entire thing and take out, calculate it, you will get your FC value as 7.608 Newton per mm square. Now calculate your modular ratio, that is your alpha E. Alpha it is alpha E, it is nothing but it is a ratio of Young's modulus of steel to Young's modulus of concrete, that is ES by EC. ES value also it has been given in the question itself, that is 2 into 10 to the power of 5, and your EC value also has been given. So your alpha E value will be 6.66. Now you calculate your percentage of loss, you calculate your loss. Loss is 5 into FC into alpha E. So 5 is 1.5. Phi value, that is creep coefficient value. In the question they have given it, they have mentioned it, and FC you have calculated over here, so that is 7.608, and alpha E again you have calculated this, so you will get your loss as 76.08 Newton per mm square. So next is problem number 2, second problem of your creep coefficient, loss of creep coefficients, creep of concrete. So that is problem number 2. A concrete beam of rectangular section 100 mm wide and 300 mm deep is pre-stressed by 5 wires of 7 mm dia located at an eccentricity of 50 mm. The initial stress in the wire is 1200 Newton per mm square. Estimate the loss of stress due to creep of concrete using the ultimate creep strain method and creep coefficient of method. They are asking in both the methods. One is ultimate creep strain method and creep coefficient of method. So Young's modulus of the steel also has been given, that is 210 kilonewton per mm square, and Young's modulus of the concrete has also been given, that is 35 kilonewton per mm square. And they have given epsilon cc also, that is ultimate creep strain. So that is 41 into 10 to the power of minus 6, and psi, that is creep coefficient also has been given, that is 1.6. Okay. Now write down all the given data. The first breadth is 100 mm and depth is 300 mm. So next dia of bar also, dia of the wire also has been given, so that is 7 mm dia of. Okay, so next number of wires also has been given, so that is 5 numbers. Next, initial stress in a wire is been given 1200 Newton per mm square. Young's modulus of the steel is 210 kilonewton per mm square, and Young's modulus of the concrete it is 35 kilonewton per mm square, and epsilon cc, that is ultimate creep strain, that is 41 into 10 to the power of minus 6, and the psi, that is creep coefficient, is 1.6. First let us know what is ultimate creep strain method and what is creep coefficient method formula. Ultimate creep strain method formula is epsilon cc into fc into es, whereas creep coefficient method is psi into fc into alpha e. So here epsilon cc is known, they have given epsilon cc value as 41 into 10 to the power of minus 6. Whereas fc, you need to calculate your fc is what, P by A plus Pe by Z. And Es is known, that is Young's modulus of steel, 210 kilonewton per meter square. So first method, ultimate creep strain method. In this you need to calculate your P value, okay, because here they have given an initial stress. Okay, they have not given only a stress, they have not given. So initial stress they have given, P value you need to calculate 1200 is stress, P divided by A. A is, they have given 7 mm dia of 5 numbers, pi by 4 into d square into number of bars. So that is, when you calculate that, your P value will be 230.9 kilonewton. So next, calculate your stress value, 230.9 kilonewton. So in this again calculate your stress. So calculate your stress, direct stress, F equals P by A. P is 230.9 into the power of 3 and A is area of your rectangular section, 100 by 300. You will get your F value as 7.69 Newton per mm square. Next, what else you need? P by Z. You know, right? FC equals P by A plus PE by Z. P by A you calculated over here, 7.69. Whereas PE by Z, P is also known, E is also known. E is 50 mm eccentric distance, they have given it. And Z is nothing but BD cube by 12 divided by Y. B is 100 and D is 300 cube divided by 12 divided by Y. Y it is nothing but E. E is nothing but eccentric distance. So that value is 4.5 into 10 to the power of 6 mm cube. So substitute to our formula, that is our ultimate creep strain formula. Loss equals epsilon cc, in the question itself has been given. Fc you have calculated over here, and Es, that is Young's modulus of steel, substitute that, you will get your value as 88.25 Newton per mm square. Now let us deal with second method, so that is creep coefficient method. Okay, loss equals phi, that is your nothing but your creep coefficient, into Fc, that is nothing but your strain stress in the concrete at the level of steel, and alpha E, it is nothing but your modular ratio. Substitute entire value, you know all the values. Fc also has been calculated, the same thing, and alpha E, calculate your alpha E, that is Young's modulus of steel to a Young's modulus of concrete. So when you calculate, substitute that, you will get your value as 98.4 Newton per mm square. So next, the third problem of loss of creep in strain, creep in concrete. So that is, third problem is a post tension concrete beam of rectangular section 100 mm wide and 300 mm deep is stressed by a parabolic cable. Okay, underline that, parabolic cable, with zero eccentricity at the support. Please understand the question. With zero eccentricity at the support and an eccentricity of 50 mm at the center of span, the area of the cable is 200 mm square and initial stress in the cable is 1200 Newton per mm square if the ultimate creep strain is 30 into 10 to the power of minus 6, that is your epsilon cc, and Es equals 210 kilonewton per mm square. Calculate the loss of stress in the steel due to creep of concrete. Okay, so they are asking loss of stress you need to calculate in the creep of concrete. So they have given, they have not given a phi over here. It means the creep coefficient has not been given, and they have not mentioned the age also. Okay, so here only they have given a epsilon cc value. It means you need to calculate the loss in the method of ultimate strain method. Okay, ultimate strain coefficient method alli calculate ಮಾಡಬೇಕು. So write down all the given data. One is breadth has been given 100 mm and depth also has been given 300 mm, and they have given an eccentric distance also. Look at this diagram. I have taken a rectangular section, so 100 mm wide and 300 mm deep. This is your neutral axis. In the question they have mentioned this is in a parabolic cable with the eccentricity is 0 at the support, and at the middle the eccentric distance is 50 mm. Okay, so I have taken that. So now calculate your stress. stress is P by A. Initial stress has been given 1200. Here they mentioned the initial stress in the cable is 1200 Newton per mm square. Okay, so take on that initial stress 1200. P by A, area of the cable also has been given 200. So you get your P value as 240 kilonewton. When the eccentric distance is 0 at the support, direct stress equals F equals P by A. F equals 240 divided by A is area of your rectangular section. So next, so when this 0, you need to calculate. So for eccentricity is 50 mm. For ultimate creep strain method, loss equals epsilon cc, that is ultimate creep strain. It has been given in the question. And FC, you need to calculate that P by A plus P by Z, okay, into Young's modulus ES. Okay, when P by A value, substitute that you have calculated in the previous only. So P by A value was 8 Newton per mm square, and P into E by Z. So P is known value 240 into 50. 50 is what is your 50? It is your eccentric distance, divided by Z. Z is what? BD cube by 12 divided by Y. B is 100 and D is 300 cube by 12 divided by Y is eccentric distance 50. So when you substitute and calculate it, you will get your value as 4.5 into 10 to the power of 6 mm cube. So all the things you need to substitute over here to this FC, epsilon cc into FC into ES. But coming to this FC, this is P by A, calculate your FC as P by A plus PE by Z, you will get your value as 10.66. But here you need to take your average stress, because the you have two eccentricity. One is 0 eccentricity and the second one is 50. So as it is in a parabolic, you need to take your average stress, that is P by A plus 2/3 of that is whole FC minus P by A. Okay, you will get your average stress as 9.77. So now you calculate your loss by ultimate strain method, that is epsilon cc, that is ultimate strain, creep strain in concrete, into FC, that is nothing but your stress in the concrete at the level of steel. Yes, that is nothing but your Young's modulus of steel. Substitute all the values, you will get your value as 61.55 Newton per mm square.